Today we are going to be going over the Unit 4 practice day. It's all concepts we've learned in Unit 4 already. Number 1, we want to find the value of the variable. So we're looking for x. Notice that we have an isosceles triangle. And remember that an isosceles triangle has two sides or two legs that are congruent. And the two legs that are congruent here are the 4x minus 5 and the 3x plus 7. And we can set those equal to each other. So 4x minus 5 equals 3x plus 7. And then subtract 3x from both sides. And add 5 to both sides. And that gives us x equals 12. On our next one, again, we're finding the value of the variable. And we have remote interior angles, and we have exterior angles, one exterior angle. And that exterior angle is 3x minus 7. And remember how we set up when we have remote interior angles and an exterior angle is that the exterior angle, 3x plus 7, equals the two remote interior angles added together, x minus 12 plus 3x minus 23. Then we can combine our like terms, which gives us 3x plus 7 equaling 4x minus 35. Subtract 3x from both sides and add 35 to both sides. And that gives us 42 equaling x. Our next one, we have two triangles, and we know they're congruent. That these angles are congruent because of the third angles theorem, also because of angle side angle, because we know this side is congruent to itself. So we can set those two angles equal to each other. 2x minus 5 equals x plus 16. Solve for x. Subtract x from both sides, add 5 to both sides. And that gets us x equals 21. Our next one, we are classifying each triangle by its angle measures. It gives you options. So our first triangle that we are looking at is triangle DBC. We have all the angles in that triangle. We have 70, 60, and 50, and all three of those angles are acute. So this is an acute triangle. Our next one we are looking for is triangle ACB. Triangle ACB is our largest triangle here. And angle ABC is 70 degrees. Angle C is 60 degrees. And we need to find angle A. So 70 plus 60 is 130, and then we subtract that from 180. And that gives us 50 degrees for the measure of angle A. So we've got 50 degrees, 70 degrees, and 60 degrees, which again means this is an acute triangle because all of the angles are acute. And then we are looking for triangle ADB. So this triangle, we have a 50-degree angle and a 20-degree angle. We need to find angle ADB. So we're going to add the two angles we know, 50 plus 20, that gets us 70, and then subtract from 180, and that gets us 110 degrees for angle ADB. So we have a 50-degree angle, a 20-degree angle, and a 110-degree angle. And since we have one obtuse angle, that means we have an obtuse triangle. Our next set of examples, we are classifying each triangle by their side lengths. Again, we have the options listed. Our first triangle that we are looking at is triangle ABC. Triangle ABC is our largest triangle. And we have a side of 10, a side of 6, and a side that we only know part of is 5. And this is a scaling triangle because we can't assume that this is either 1 or 10, and it appears to not be the same size as the others. So this is scaling because no sides are congruent. And then we're looking at triangle ADC. And triangle ADC has a side of 5, another side of 5, and a side of 10. So it has two sides that have the same length, which means that this is an isosceles triangle. Our next set of questions asks, two angles of a triangle are given. What is the measure of the third angle? Then classify the triangle as acute, right, or obtuse. So we need to find the missing angle measure. So we need to add those two angles together, 24 plus 49. And that gets us 73. And then subtract 73 from 180. And that gets us 107 degrees. And we have 24, 49, and 107 for our angle measures. That means we have an obtuse triangle because one of those angles is obtuse. Doing the same thing on this next one. So we're going to add the two angles that were given to us. And that gets us 90. Subtract it from 180. And that gets us 90 degrees. And we have an angle of 84 degrees, 6 degrees, and 90 degrees. So that's a right triangle since we have one right angle. On our next one, we are looking for angle CBE. CBE. So this angle down here. We know we have 28 degrees here, and we have, again, an isosceles triangle. And remember that your base angles in an isosceles triangle are congruent. So angle D is also 28 degrees. And that means that we can find angle ACD by adding 28 and 28 and then subtracting from 180. And then we can take and that 124, subtract it from 180, get 56, and then divide by 2, and that gets us 28 degrees for angle CBE. Now, I could have also done this because AD and BE are parallel. Know that angle D and angle B are congruent because they are alternate interior angles. Next up, we want to find the measure of angle N. Again, we have an isosceles triangle, and again, we know that our base angles in an isosceles triangle are congruent. So we can set 7x plus 5 equal to 4x plus 29. And then subtract 4x from both sides. And subtract 5 from both sides. Gives us 3x equaling 24. And then divide by 3. And x equals 8. But we weren't just looking for x, we are looking for the measure of angle N. So we need to substitute for the measure of angle N. So 7 times 8 plus 5. So 7 times 8 is 56, plus 5 is 61 degrees. Our next one, we have an equiangular triangle because all of the angles are equal. And since we have an equiangular triangle, we know we have an equilateral triangle, meaning that these sides are congruent as well. That tells us that we can set these sides equal to each other. 5x plus 7 equals 8x minus 18. We're going to add 18 to both sides and subtract 5x from both sides. That gives us 25 equaling 3x. Divide by 3 on both sides, and x equals 25 thirds. Yes, leave your answer as a fraction. Our next one, we want to solve for y, and we have an equilateral triangle. And since we have an equilateral triangle, we know that all of the sides are congruent and all of the angles are congruent. And each one of these angles is 60 degrees. And since each one of those angles is 60 degrees, we can set 5y minus 15 equal to 60 and solve for y. So we're going to add 15. Gets us 5y equals 75. Divide by 5 on both sides. So y equals 17. Then our next one, we have an isosceles triangle again. Remember, your base angles are congruent. So angle D and angle E are congruent. That means angle E is also in degrees. Now we have an angle, something about each of those three angles. So we can add those three together. 3n plus n equals 180. Combine our like terms. That gets us 5n equals 180. Divide by 5 on both sides. And n equals 36. Okay, and then next up, we're given that triangle NOP is congruent to triangle RST, and we want to identify the congruent corresponding parts. First off, we're looking at segment RS. Notice that RS were the first two letters in the second triangle. So we want the first two letters in the first triangle. So we want segment NO. Now, if you're typing this on a computer, you need to tell me segment NO. Make sure that N and O are capitalized. Yes, you need the word segment in front of it because you are telling me what you have. Our next one, we're looking at angle P, which is the last letter in the first triangle, and the last letter in the second triangle is angle T. So angle P is congruent to angle T. Again, if you were typing this on a computer, you need to write out the word angle and then make sure you have a capital T. Next up, the ratio of the side lengths of a triangle is 2 to 3 to 5, and its perimeter is 54 meters. What is the length of the shortest side? So we are dealing with the side lengths of the triangle. And remember that anytime you have a ratio of numbers like this, more than just 2, we're going to put an X with each of those numbers. And we are going to add them together. That gets us one side of our equation. And in this case, we're dealing with perimeter, and it gave us our perimeter. So that's the other side. We're going to combine our like terms. So 10x equals 54. Divide by 10. And x equals 5.4. And we were looking for our shortest side, so we need to plug it in. Our smallest number was 2. So 2 times 5.4 gets us 10.8 meters, and that's our shortest side. Next up, we want to solve the proportion 16 over 12 equals x over 4. Remember that we cross multiply. So 16 times 4 equals 12 times x. And 16 times 4 is 64 equals 12x. And then divide by 12 on both sides. And that gives us 16/3 once we reduce our fraction. Next up, we want to write a ratio expressing the slope of each line. The first one we're looking for is L. Remember that slope is rise over run. Remember that we go up or down first and then to the right every time. So for L, we're going up, +4, and to the right, +4 as well. So that is 4 over 4, which reduces to 1. Make sure you are reducing your fractions. Then for the slope of line M is this blue line. We're going down, -2, and to the right, +3. So this is -2/3, and that is already reduced. Make sure you're using your notes.